So the reason is that this approximation formula is reasonable only if the higher order terms are negligible. Okay, so in fact, secretly, there's more terms. This is only an approximation. There would be terms involving third derivatives and maybe even beyond that. And so in the non-degenerate case, they don't actually matter because the shape of the function, the shape of the graph is actually determined by the quadratic terms. But in the degenerate case, see, if I start with this and I add something even very, very small along the y-axis, then that can be enough to bend this valley slightly up or slightly down and turn my degenerate point into either a minimum or a saddle point. And I won't be able to tell until I go further in the list of derivatives. So in the degenerate case, what actually happens depends on the higher order derivatives. So we'd need to analyze things more carefully. Well, we are not going to bother with that in this class. So we'll just say, well, we cannot conclude. Okay? I mean, you have to realize that in real life, you have to be extremely unlucky for this quantity to end up being exactly 0. Well, if that happens, then what you should do is maybe try by inspection, see if there's a good reason why the function should always be positive or always be negative or something. Or, plot it on a computer and see what happens. But otherwise, we can't conclude. Okay, so let's do an example. So probably I should leave this on so that we still have the test with us. And instead, okay, so I'll do my example here. Okay, so let's do an example. Let's say I look at f of xy equals x plus y plus 1 over xy, where x and y are positive. So I'm looking only at the first quadrant. Okay, I mean, I'm doing this because I don't want this denominator to become 0. So I'm just looking at that situation. So let's look first for... So the question will be, what are the minimum and the maximum of this function? So the first thing we should do to answer this question is look for critical points. Okay? So for that, we have to compute the first derivatives. Okay, so f sub x is 1 minus 1 over x squared y. Okay? Take the derivative of 1 over x, that's negative 1 over x squared. And we'll want to set that equal to 0. And f sub y is 1 minus 1 over xy squared, and we want to set that equal to 0. So what are the equations we have to solve? Well, I guess x squared y equals 1. I mean, if I get this, if I move this guy over here, I get 1 over x squared y equals 1. That's x squared y equals 1. And xy squared equals 1. What do you get by comparing these two? Well, x and y should both be, okay, so yeah, I agree with you that 1 and 1 is a solution. Why is it the only one? So first, if I divide this one by that one, I get x over y equals 1, so that tells me x equals y. And then if x equals y, then if I put that into here, it will give me y cubed equals 1, which tells me y equals 1, and therefore x equals 1 as well. Okay, so there's only one solution. There's only one critical point, which is going to be 1, 1. Okay. So now, here's where you do a bit of work. What do you think of that critical point? Okay, I see some valid votes. I see some. Okay, I see a lot of people answering 4. That seems to suggest that maybe, well, you haven't computed the second derivative yet. Yes, I see someone giving the correct answer. I see some people not giving quite the correct answer. I see more and more correct answers. Okay, so let's see. To figure out what type of point it is, we should compute the second partial derivatives. Okay, so f sub xx is, what do we get when we take the derivative of this with respect to x? 2 over x cubed y. Okay? So at our point, a will be 2. F sub xy will be 1 over x squared y squared. So b will be 1. And f sub yy is going to be 2 over xy cubed. So c will be 2, and so that tells us, well, ac minus b squared is 4 minus 1. Sorry, I should probably use a different blackboard for that. AC minus b squared is 2 times 2 minus 1 squared is 3, is positive. That tells us we are either a local minimum or a local maximum. And A is positive, so it's a local minimum. And in fact, you can check it's the global minimum. What about the maximum? Well, the maximum is not actually at a critical point. It's on the boundary or at infinity. See, so we have actually to check what happens when x and y go to 0 or go to infinity. Well, if that happens, if x or y goes to infinity, then the function goes to infinity. Also, if x or y goes to 0, then 1 over xy goes to infinity. So the maximum, well, the function goes to infinity when x goes to infinity, or y goes to infinity, or x and y go to 0. So it's not at a critical point. Okay, so in general, we have to check both the critical points and the boundaries to decide what happens. Okay, the end. Have a nice weekend.